My name is Grzegorz. Lesiuk. I work at the Wrocław University of Science and Technology, Faculty of Mechanical Engineering. I'm associate professor, and of course, I'd like to share with you some results, observations, maybe inspirations for further analysis and thinking the ways about the description of fatigue growth rate. Even if we are in the TC12 committee, so it's extremely important for the further predictions using the models. Let's go to the main point. Maybe I will skip the outline of the presentation because it's too short to discuss, but in general, I'd like to show you some approaches based on the energy for avoiding mean stress effect. Motivation is always the same. So as we discussed about the fatigue lifetime prediction, dependent it is fatigue or fatigue growth rate, we are still in the same position because in both cases we have a problem with the description of invariant description, fatigue growth process or fatigue independent from stress ratio. Of course, if you add some crucial points like multi-axiality and many other aspects, we are in the almost worst case. Let's see on this my favorite diagram, which I found in the literature, and also not the damage because we can discuss about the damage large structures long time. But if we look to the wind turbines or bridges, we see that the load irregularity and of course the required number of cycles to failure is high. So of course, S355 still is very popular in common sections. Coming straight to the points in calculation of crack growth rate or precritical period of crack growth, we will have all models. Mostly of them are semi-empirical. Of course, I brought just few old. Of course, old theory looks always good, and probably the most recognized, like E equal mc square in physics, is the Paris law model, which is used by many researchers. It's the simplest, is the easiest way.
Base for all other.
Yes, industry love it. Of course, we can discuss in some aerospace industry, maybe using Nasgro model or others more complicated, but estimation of some parameters is crazy. We started many years ago with also my mentors, and not only by new generation of the energy approach based on the thermodynamics, and of course it is a energy balance, and also presented today by Professor Vilio, kind of concept of the brick models and fatigue of elementary bricks perfectly fits in this line. Maybe I can go to just the final conclusion, which is of course included in the paper performed by Professor Shata and me in 2009. We can see that if we use some specific energy components for the description and the composition of the energy by cyclic and static component, we can calculate or propose not only one. This is just of the one representative group of the models, which is based on dissipated energy. Of course, I'd like to discuss a long time about it, but the time is limited. What is the meaning of proper energy in cyclic loading? So where we need to measure this energy. In our case, we selected dissipated energy in each cycle of loading based on the hysteresis loops. But of course, you can see in this new delta H quantity, we have also K1 max, which is of course referred to the maximum value of stress intensity factor, as well a critical fatigue stress intensity factor. Typically, organization of the measurement stand is more or less similar to classical ASTM 647, but of course, it's a problematic to measure the area under the hysteresis loop due to very small changes. Of course, colleagues that they are working in fatigue, they are more happy because the loop is much more larger and wider. And in this case, it is also involved in HP Hewlett-Packard V environment, a special procedure for proper measuring the energy in situ during the experiment. And as we can see, it's Polish grade 18G2A, but it's internationally recognized as S355. We can see that for different stress ratios, we have for mode 1, of course, for different stress ratios are shifted curves, which is of course typical for various aspects. But if we use energy component, we have all points consolidated into one line. And in the next steps, we tried to combine energy parameter, building new energy parameter, of course, analyzing the literature with the concept of static and cyclic plastic zones. And as we can see, of course, we can find in the literature some links to cyclic J integral. Of course, this is a long discussion also in the literature if the cyclic J integral, well, should be called J integral still, or maybe we can treat it as an energy parameter and interpretation of the differences in the potential energy in growing cracks. Anyway, if we propose, for instance, elastoplastic energy parameter, we can see, for instance, delta S star, like in similar to Kwiatkowski model in the elastic stress intensity factor range. It's positive part of delta J as well J max. And then we validated it for not only mode 1, but also mixed mode loading. I can show you just for, again, for mode 1, for different stress ratios, we can see even if we replace delta K by elastoplastic parameter, delta J calculated numerically or, of course, developed using numerical algorithms, you can see that we also still have the problem with the stress ratio effect, which is inherent part of the description of this process. But if we use two parametric models, driving force models, for the description of the static crack growth rate, we see full consistency into one line for different stress ratios. In the next steps, we tried to develop, well, validate the models also for mixed mode loading condition. From time to time, it is also vital and crucial point. Why? Because in mixed mode loading, we can state that at the final stage, everything under the mixed mode loading will tend to mode 1. But at the beginning, we are extremely interested about the crack paths and also crack growth rate under the mixed mode loading condition. Of course, there is no standards, so we are not happy like in using STM 647. But of course, there's some recommendation from the literature. We used Richard proposal from 80s about the building this type of measurement stand by special CTS specimen, and of course by different load angle we trigger different mixity ratio. And of course we are supported by numerical analysis because even sorry, can we come back? It's just one direction probably. Oh, yeah, okay, I see. Sorry, just briefly. Even if we have formulas, they are valid for stationary crack. So for static conditions, so we cannot use it anyway in the cyclic loading, but of course it's not a problem to calculate delta K, delta J, or many others energy parameters using numerical analyzing. And of course, post-processing using the tiled microscopic analysis of the crack paths, we calculate in every point, every crack front tip parameters. And then, of course, during the experiments, we have collected points for mode 1+2 and 1+3 using torsion and tension and bending in our case. And after that, for is one of the most important points to generate the kinetic fatigue fracture diagrams. Here we have with delta K approach, we can see that for delta K, delta K1, delta K3, we can separate the modes. Of course, it's very easy and known. Of course, we need to use sometimes an equivalent delta K, which is also clear what we need to do. But if we are more focused using this type of the diagrams still for any energy parameters, you can see that for delta S star parameter, for instance, this is the energy-based parameter, we cannot observe the effect of stress ratio. And, sorry, as I discussed previously, we also tested in our friends in Opole by Professor Rozumek and also co-authors of the paper under the mode 1+3. We constructed different diagrams also for S355 still. And as we also discussed, even if we used elastoplastic parameter, we have still influence of the mean stress effect for fatigue fracture diagram. And also finally, if we use energy component, we have full consistency of the data into one line. Why is so important? Going quickly to the conclusions, maybe. Because usually, typically in industrial we need to build a generalized model. For instance, we have variable amplitude or maybe different approaches. We need to every time estimate the constants for Paris law or maybe different. Of course, we can use different models, but it means that the description using delta K or delta J is still not too sufficient. We need to develop some models for generalized modeling. In our case, we are happy to announce that it works for mode 1, mode 2, and also maybe in future we need to develop for different modes. Thank you for your attention.